everyone, welcome back to the channel. Today we have with us Siddharth. He'll be going through the further mathematics May-June 2024 paper 13 with you. He'll go through each question in great detail so that you can comprehend each question and its solution. Over to you, Siddharth.
Yeah. Okay, so let's start solving the paper. So we have the first question. The matrix A is given by this one, where K is a real constant. Show that A is non-singular. So a matrix is singular when its determinant is equal to 0. So if we want to show that A is non-singular, we should show that the determinant can never be 0. So we'll do like this. So we'll take the determinant of A. So it's equal to K times 5 into minus K minus 2 into 3 minus 1 is into 6 into minus K plus 2, and when we take the 0 into this, it will just be 0. So this one will be K into minus 5K minus 6 minus 1 into minus 6K plus 2. So this will be equal to minus 5K square minus 6 plus 6 minus 2. So this minus 6 and plus 6 cancel. So we get minus 5K square minus 2. So this is the determinant of the matrix. So we know if we just plot this, it'll come something like this. This is the plot of minus 5K square minus 2. So we can see there are no intersections with the x-axis, which means that this determinant never crosses the x-axis, means it has no real solutions. So minus 5K square minus 2 is equal to 0, has no real solutions. So if it has no real solutions, means that minus 5K square minus 2 can never be equal to 0. So therefore, A is non-singular. Okay. Given that A inverse is equal to this, find the value of K. Okay, so first thing we need to know is that A times A inverse is equal to the identity matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is the identity matrix. So going back, we have A is equal to K1, 0, 6, 5, 2, and minus 1, 3, minus K. Yeah, minus 1, 3, minus K. So this times 3, 0, minus 1, 1, 0, 0, minus 23 by 2, 1 by 2, and 3. So when we multiply this out, we should get this identity matrix. So we don't need to multiply the full matrix. Instead, what we can do is just solve for one element. So let's solve for the top right. Let's simplify the top left element of this one. So it'll be 3 times K plus 1 times 1 plus 0 times minus 23 by 2, which is just 0. So this should be equal to 1. So if we get that, so we have 3K plus 1 is equal to 1. So 3K is equal to 0. And we get K is equal to 0. So this is the value of K. Okay, the cubic equation x cubed plus 2x squared plus 3x plus 1 has roots alpha, beta, gamma. Find a cubic equation whose roots are alpha squared plus 1, beta squared plus 1, gamma squared plus 1. So we can just do this by taking y is equal to x squared plus 1. Because, I'll show you why in a second. So y is equal to x squared plus 1. And if we just make x the subject, so you have y minus 1 is equal to x squared. And x will be equal to square root of y minus 1. So now when we have this, if we substitute this back in the cubic equation, the resulting equation will have these roots. So we can do this. So we have q plus 2 into square root of y minus 1 squared plus 3 into square root of y minus 1 plus 1 is equal to 0. Okay. So this we can write as y minus 1 to the power 3 by 2 plus, and this square root on square will cancel. Yeah. So y minus 1 to the power 3 by 2 plus 2y minus 2, and this minus 2 plus 1 will just become minus 1 later on. So I'll just minus 1 plus 3 root y minus 1 is equal to 0. So let's move all the non-root terms to the other side. Y minus 1 to the power 3 by 2 plus 3 times y minus 1 to the power 1 by 2 is equal to 1 minus 2y. Okay. Yeah. So now taking the square on both sides, we have like, we'll get y minus 1 to the power 3 plus 9 into y minus 1 plus 2 into y minus 1 to the power 3 by 2 into 3 to the power, 3 times y minus 1 to the power 1 by 2. And taking the square on the right hand side, we'll get 1 square, which is just 1, plus 4y square minus 2 into 2y. So it is minus 4y. And now we can expand this also. So y minus 1 cube will just be y cube plus y cube minus 3y squared plus 3y minus 1 plus 9y minus 9. Okay, plus, and this y minus 1 to the power 3 by 2 times y minus 1 to the power 1 by 2 will just become, the exponents will add, so we'll get y minus 1 just square, and it'll become 6. So this will become 6 times y squared plus 1 minus 2y, which is just plus 6y squared plus 6 minus 12y is equal to 1 plus 4y squared minus 4y. And let's just rearrange all these terms. So I have the minus 3y square plus 6y square. So that's y cube plus 3y square. And when we bring this 4y square to the other side, it'll become minus y square. We have 3y plus 9y minus 12y. So 3 plus 9 is 12. Again, minus 12 will cancel out fully. But we have 4y here. So when we move this side, it'll become plus 4y. And we have we have minus 1 here and plus 6 here. So minus 1 plus 6, that's 5. I accidentally, this one is not part of the cancellation. So it'll be, so this is the cubic equation which has those roots. So let's go to the next part. Find the value of alpha squared plus 1 square plus beta squared plus 1 square plus gamma squared plus 1 square. Okay. So keep in mind that alpha square plus 1, beta square plus 1, gamma square plus 1 are all the roots of this equation. Y cube minus y square plus 4y minus 5 is equal to 0. Okay. So this is basically the sum of the root square, which we can write like this. We can say a square plus b square plus c square. We can always rewrite it as a plus b plus c whole square minus 2ab plus bc plus ac, like this. So this sum of roots taken 2 at a time, we can write it as sum of roots whole square minus 2 times the sum of roots taken 2 at a time. So we can write it like this. So sum of roots is minus b by a. So b is here minus 1. So minus of minus 1 is just 1. 1 by 1 square minus 2 times, this one is c by a, just 4 by 1. So it's just 4. So it's 1 minus 8, which should be equal to minus 7. Okay. Find the value of, now it's this is like the previous one, except these are cubes now. So again, the equation is y cube minus y square plus 4y minus 5. So you can write alpha cube, since okay, I'll denote these as capital A, capital B, capital C, okay, from now onwards. So since these are all roots of the equation, we should be able to substitute them like this: alpha cube minus alpha square plus 4 alpha minus 5 is equal to 0. B cube minus b square plus 4b minus 5 is equal to 0. C cube minus c square plus 4c minus 5 is equal to 0, right? So now when we add these three equations, we get alpha cube plus, a cube plus b cube plus c cube minus alpha square plus b square plus c square plus 4 times a plus b plus c, and minus 5 minus 5 minus 5 becomes minus 15. Okay. So now we're trying to solve for this. So we already know the value of this from the previous one. It's just minus 7. So alpha cube plus beta cube plus c cube minus of minus 7, which is plus 7, plus 4 times, this is going to be minus b by a, which is just 1, minus 15 is equal to 0. So a cube plus b cube plus c cube is going to be equal to 15 minus 4 minus 7, which is 4. Is it? Yeah. So that's the answer for this one. The matrix M is given by 1, 2. So it's a combination of two matrices. So the matrix M represents a sequence of two geometrical transformations in the xy plane. Give full details of each transformation and make clear the order in which they are applied. Okay. So we have a combination of two matrices first here. So always it's like functions. So when you see f of g of x, the innermost one is applied first, right? And then the outermost one. So similarly, the rightmost one is always applied first, then the left one. Just a second. Yeah. So the first matrix which is applied is this one, 7, 0, 0, 1. So let's see what it like actually represents on the geometrical plane. So this is the xy plane, and this is the vector I hat, which has coordinates 0, 1, and this is the vector j hat, which has, it's actually 1, 0, and this is the vector j hat, which has the coordinates 0, 1. So what the first column of the matrix represents is how much I hat, where the I hat goes. So this goes to the place 7, 0. So all the corresponding vectors will also get stretched like that. So this matrix actually represents a stretch parallel to the x-axis by factor 7. And then the second one, it's 1, 2, 0, 1. Just erase this. So now, so the I hat vector stays the same at 1, 0, where it already was. This second column, 2, 1, represents where the j hat vector will go. So this will go, before it was here, so now it's here. So this is the place 2, 1. So this type of transformation where the y-axis is kind of tilted, this represents a shear. So this is a shear with the x-axis fixed. And this is by so what happens is that the 0 1 is mapped to 2 comma 1. Yeah. Okay. So find the equations of the invariant lines through the origin of the transformation represented by M. Okay, so let's first find out what M is. So M they gave here is a combination of two matrices. So M is equal to 1 2 0 1 times 7 0 0 1. So if we just simplify this, we get 1 times 7 plus 2 times 1. I mean 1 times 7 plus 2 times 0. So it's just 7. And for the top right, we have 1 times 0 plus 2 times 1, which is just 1. Sorry. Oh. I'll just take this again. Okay. Okay, so for this part, find the equations of the invariant lines to the origin of the transformation represented by M. So they gave the matrix M as a combination of 2, so we'll just combine them into 1. So we have M is equal to 1 2 0 1 times 7 0 0 1. Okay, so if you have a calculator, you can just directly do it on the calculator itself, but I'll still do it here for you guys. So we have multiply the corresponding column with the corresponding row. So 1 times 0 plus 1 times 7 plus 0 times 0, which is just 7. Then we have, for this one, we have 7 plus, okay, so 1 times 7 plus 2 times 0. And for this one, we have 1 times 0 plus 2 times 1, which is 2. For the bottom left one, we have 0 times 7 plus 1 times 0, which is just 0. And for the bottom right one, we have 0 times 0 plus 1 times 1, which is just 1. So this is the matrix M. So invariant line means all the points on a line, on that invariant line, are just mapped onto the same line. So we can model it using y is equal to mx. So suppose a point x comma y is there. So even after the transformation, it will get mapped onto a point on the same line, which is x prime and y prime. And we can write this as such: 7x plus 2y is equal to x dash, and y is equal to y dash. Okay, and since it's a line, it's a linear line, we can write y as in terms of x and m. So we have 7x plus 2mx is equal to x dash, and mx is equal to mx dash. So we have x dash here, we can substitute it here. So mx is equal to m into 7x plus 2mx. So cancelling out all the x's. So we have m is equal to 7m plus 2m square. We have 2m square is equal to 2x square plus 6m is equal to 0. So one solution is obviously m is equal to 0, in which case the line would be y is equal to 0x, which is just 0. And another solution will be 2m square is equal to minus 6m. And you do it like that: 2m is equal to minus 6, m is equal to minus 3. So another solution will be y is equal to minus 3x. So that's for this one. The triangle DEF in the xy plane is transformed by M onto the triangle PQR. So some triangle DEF is there, and after that transformation, it's like mapped onto some other triangle. Given that the area of triangle PQR is the resultant triangle, find the area of the original triangle DEF. So whenever any shape is there on the xy plane after the geometrical transformation, its new area will be the old area times the determinant. Like this. So the new area they gave as 35. So old area times determinant of m. Determinant of m, we have that m is 7201. So determinant will be AD minus BC. So 7 times 1 minus 2, which is just 7. So old area is equal to 35 by 7, which is just 5. Okay. Prove by mathematical induction that for all positive integers n, this sum of r square from 1 to n is equal to 1 by 6n into n plus 1 into 2n plus 1. Okay. So for proof by mathematical induction, it's always the same format. So you have to check base case. Base case means now the lowest value n can take is 1. So you have to try for 1. So for n is equal to 1, we have summation from r is equal to 1 to 1 of r square. It's just 1 square. It's just 1. And if we check with the formula, it'll be 1 by 6 times 1 times 2 times 2 times 1 plus 1 is 3. So it's just 6 by 6, which is equal to 1. So it's true for n is equal to 1. Now let's assume that it's true for n is equal to k. For n is equal to k. So what will that mean? So r is equal to 1 from 1 to, when you take the sum from 1 to k of r square, you get 1 by 6 times k plus 1 times 2k plus 1. Okay? Okay, so we have a new slide. I'll continue it over there. So we have summation from r is equal to 1 to k of r square is equal to k into k plus 1 into 2k plus 1 by 6. And now let's check for n is equal to k plus 1. So we have to sum from r is equal to 1. So to k plus 1 of r square, this will just be equal to the sum from r is equal to 1 to k of r square plus k plus 1 square. And now we have this one, so let's just substitute this here. So we have k into k plus 1 into 2k plus 1 by 6 plus k plus 1 square. So now factoring out the k plus 1, we have k into 2k plus 1 by 6 plus k plus 1. So multiplying by 6 on top and bottom. And then we have k plus 1 by 6 into k into 2k plus 1 into 6k plus 6. We have, I'll erase this part. Okay, so you have k plus 1 by 6 into k into 2k plus 1 into 6k plus 6. Actually, just a second. Plus 6k plus 6. Yeah. So we have k plus 1 by 6 into k into 2k plus 1 plus 6k plus 6. This we can simplify as such as 2k square plus k plus 6k plus 6. And if we actually just factor this out, we get 1 by 6 into k plus 1 into k plus 2 into, so just 2 into k plus 1 plus 1, which is 2k plus 3 into 2k plus 3. So you can kind of work backwards. So you should, if you substitute k plus 1 into this formula, you'll be getting the same thing. So now that we know that the formula is holding consistent for n is equal to k plus 1 also by the principle of mathematical induction. So we have to write the statement during the exam. It's like, since formula holds true for n is equal to 1, k and k plus 1 by the principle of mathematical induction, it holds true for all positive integers. So that's how you finish this proof. For a, okay, just a second. Yeah, so that's this question. So next question is, the sum Sn is defined by Sn is equal to this, the sums of the fourth powers. So using this identity, 2r plus 1 to the power 5 minus 2r minus 1 to the power 5 is equal to 160r to the power 4 plus 80r square plus 2. We need to prove this thing to be true. Okay. So let's begin by taking the summation on both sides from r is equal to 1 to n of 2r plus 1 to the power 5 minus 2r minus 1 to the power 5. So just what will this be equal to? So we'll substitute 1 and check. So when we substitute r is equal to 1, for the first part it will be 2 into 1 plus 1 to the power 5, which is 3 to the power 5, minus 2 into 1 minus 1, which is just 1 to the power 5. So then we add the next one, r is equal to 2. 2 times 2 to plus 1, which is 5 to the power 5, minus 2 times 2 minus 1, which is 3 to the power 5, and so on. 2 times 3 plus 1, which is 7 to the power 5, minus 5 to the power 5, so on and so forth, until we get 2n plus 1 to the power 5 minus 2n minus 1 to the power 5. So now we'll note this thing. So this 3 to the power 5 and minus 3 to the power 5 cancel out. 5 to the power 5 minus 5 to the power 5 cancel out. So on and so forth. These all cancel out until didn't mean to cancel that. Until we're left with 2n plus 1 to the power 5 minus 1 to the power 5, which is just equal to 1. Okay, so this is the left hand side. Now let's check our right hand side. Okay, so on the right hand side we have the sum of 160 r to the power 4 plus 80 r square plus 2. So this is just going to be 160 times sum of r to the power 4, which is what we're trying to find, plus 80 times sum of r square. And we already know from the previous part that r square is equal to n into n plus 1 into 2n plus 1 by 6. So this just becomes n into n plus 1 into 2n plus 1 by 6. And we have the sum of 2, which is sum of 2 from r is equal to 1 to n, which is just 2n. Okay. So now all we need to do is just isolate this part. So we'll do that on the next slide. So we have 160 times sum of r to the power 4 plus 80 n times n plus 1 times 2n plus 1 by 6 plus 2n is equal to 2n plus 1 to the power 5 minus 1. Okay, so we have 2n plus 1 to the power 5 minus 1 minus 2n minus 80 by 6 times n plus 1 to the power 2n plus 1. Okay, and when we divide this by 160, we have 2n plus 1 to the power 5 minus 1 minus 2n minus 80 by 6 into n plus 1 into 2n plus 1 divided by 160. And working backwards, you'll be able to find out that this sum of r to the power 4, it's equal to 1 by 30 times n into n plus 1 into 2n plus 1 into 3n square plus 3n minus 1. So you can just kind of work backward and solve it out. Okay, so this question is asking find the value of the limit of n to the power minus 5 times s of n to the sum of r to the power 4 as n tends towards infinity. So we know from the previous part that this sum is equal to 1 by 30 times n plus 1 times 2n plus 1 times 3n squared plus 3n minus 1. So if we just divide it by n to the power 5, what do we get? This cancels out. So we get 1 by 30 times n plus 1 times 2n plus 1 times 3n squared plus 3n minus 1. This is all times 1 by n to the power 4. And this we can simplify as 1 plus 1 by n times 2 plus 1 by n into 3 plus 3 by n minus 1 by n square, all divided by 30. So as n tends towards infinity, all these parts which have n in the denominator will be tending towards 0. It becomes 1 plus 0 into 2 into 3 divided by 30. So this becomes 6 by 30, which is just equal to 1 by 5. So that's the C part. Okay. The lines L1 and L2 have equations r is equal to 1 plus, I'll write it like this, 1, 4 minus 1 plus lambda 0, 1 minus 2. And the other line r is having minus 3, 4, 0 plus mu times 1, 2, 1. So find the shortest distance between L1 and L2. So the shortest distance formula is equal to A2 minus A1 cross dot product of B1 times B2 divided by the square root of B1 times B2. So what's A2 minus A1? A2 and A1 are the fixed components. So it's going to be A2 minus A1 is equal to minus 3, 4, 0, minus 1, 4, minus 1. So this becomes minus 4, 0, 0, minus 1 is just 1. And let's take this dot product also. So b1 dot b2 is equal to ijk of, 1 second. Yeah. So ijk of these direction vectors. So 0, 1, 2 and 1, 2, 1. So again, you can solve this using a calculator, but I'll just solve it in front of you guys. So this will be equal to I times 1 times 1 minus 2 times 2, which is minus 3. And we have 0 times 1 minus 2 times 1, which is minus 2, but since it's j, we have to put the minus sign in front, so it's 2. And for k, it's 0 times 2 minus 1 times 1, which is just 1, minus 1. So minus 3 minus 2, 1. It's 0, 1 minus 2. So this becomes actually 1 times 1 plus 2 times 2. So this becomes 5. Yeah. So now just applying all this in the formula. So when you put this in the formula, so a2 minus a1 is minus 4, 0, 1. So dot 5, 2 minus 1 divided by square root of 5 square plus 2 square plus 1 square. So this becomes minus 20 plus 0 minus 1 divided by square root of 25 plus 4 plus 9, which is square root of 30. So it becomes, and we have to take the absolute value also. So this distance is equal to 21 by root 30, which is, if I just put it in a calculator, we get 3.83, like that. D is equal to 3.83. So that's this part done. The plane pi 1 contains L1 and is parallel to L2. So there's some plane like this. So the line L1 passes straight through it, and it also is parallel to L2. Obtain an equation of L1 in the form of PQ plus QY plus RZ is equal to S. So in order to find the equation of a plane, what we need is two direction vectors of the plane and one point on the plane. So once we have the two direction vectors, since it contains L1, it contains a direction vector of L1 also, which is 0, 1, minus 2. And since it's parallel to L2, it has the direction vector of L2 also, which is 1, 2, 1. We already calculated this previously. It's 5, 2, minus 1. And let's take a point on the plane. Since it contains L1, it's going to contain 1, 4, minus 1 also. So we can do it like this. 5, 2, minus 1 times x, y, z is equal to 5, 2, minus 1 times, what's the point? 1, 4, minus 1. So we get 5x plus 2y minus z is equal to 5 plus 8 plus 1. So it is 5 plus 8 plus 1. No, this should be minus 2 also. Minus 2 minus 1. Yeah, it's because I forgot to put this minus sign here. Okay, so it's 5 minus 2 minus 1. It doesn't change this answer because when you square everything, it automatically gets positive. Okay, 0, 1 minus 2. 5 minus 2 minus 1. So we have 5x minus 2y. Five x minus 2y minus z is equal to 5 minus 8 plus 1. 5x minus 2y minus z is equal to minus 3 plus 1, which is minus 2. So this is the equation of pi 1. Okay, next question. The point 1, 1, 1 lies on the plane pi 2. It is given that the line of intersection of the plane pi1 and pi2 passes through the points 0, 0, 2 and is parallel to the vector 1, 4, minus 3. Obtain an equation of pi2 in the form ax plus by plus cz is equal to d. Okay, the point 1, 1, 1. So there's a plane pi2 like this. It contains the point 1, 1, 1. So it's given that the intersection of the planes pi1 and pi2, so they intersect like this and they create a line of intersection. It passes through the point 0, 0, 2 and is parallel to the vector 1, 4, minus 3. So that's the direction vector. So that one of the direction vectors of this plane is 1, 4, minus 3. Obtain an equation of pi2 in the form ax plus by plus cz is equal to d. Okay, so we have this point 0, 0, 2, and we also have another point on the plane which is 1, 1, 1. So the direction of this can also, the point pq, it can also help us find the direction vector of the normal vector of the plane. So let's take 1, 1, 1 minus 0, 0, 2. So when you take this, we get 1, 1, 1 minus 2 is just minus 1. And so this is one direction vector, and we have one more direction vector as 1, 4, minus 3. So let's take the cross product. ijk is 1, 4, minus 3, 1, 1, minus 1. So we get I is, the first part will be 4 times minus 1, which is minus 4, minus 3 times 1, which is plus 3. For j, we have 1 times minus 1, which is minus 1, minus 3 times 1, which is plus 3. But because it's j, again we have to put the minus. For k, we have 1 times 1, minus 4, which is just minus 3. So we have minus 4 plus 3 is minus 1. Minus 1 plus 3 is 2. So this becomes minus 2. So it becomes minus 1, 2, minus 3. Minus 1, minus 2, minus 3. Okay. So same like we did before, what we need to do is we need a point at the plane, and we just do the dot product of that, and then we get the equation. So we have minus 1, minus 2, minus 3 times x, y, z is equal to minus 1, minus 2, minus 3 times 1, 1, 1. So we have minus x, minus 2y, minus 3z is equal to minus 1, minus 2, minus 3. So minus x minus 2y minus 3z is equal to minus 6. Or x plus 2y plus 3z is equal to 6. Yeah, so that's the solution for this one. The curve C has equation y is equal to x plus 1 divided by x squared plus 3. Show that C has no vertical asymptotes and state the equation of the horizontal asymptote. Show that C has no vertical asymptotes. So vertical asymptotes happen when the denominator is equal to 0. So if we check x squared plus 3 is equal to 0, if x squared is equal to minus 3, and x is equal to square root of minus 3. So this is imaginary. There are no real solutions for this equation. So that means that there will be no vertical asymptotes. And state the equation of the horizontal asymptote. So let's note this, that the degree of the denominator is greater than the degree of the numerator. So when that happens, the horizontal asymptote is always y is equal to 0. Find the coordinates of any stationary points on C. Okay, so stationary points happen when the dy by dx is equal to 0. So let's calculate the dy by dx of this one. So we have x squared plus 3, which is denominator. So I'll tell you the formula now for if you have a function like this, f of x divided by g of x, the derivative will be g of x times f prime of x minus f of x times g prime of x divided by g of x whole square. Okay, so x square plus 3 times the derivative of the numerator, which is just 1, minus x plus 1, the derivative of x square plus 3, which is 2x, divided by x square plus 3 whole square. So this is equal to 0. So when we just multiply both sides by x square plus 3, it just cancels out this denominator. So 0 is equal to x square plus 3 minus 2x into x plus 1. So x square plus 3 minus 2x square plus 2x is equal to 0. So we have x square minus 2x square plus 3 minus 2x is equal to 0. We have minus x square minus 2x plus 3 is equal to 0. So just solving this with the calculator, x is equal to 1 and x is equal to minus 3. Okay, so, and when x is equal to 1 and x is equal to minus 3, we have y is equal to, okay, at x is equal to 1, we have 1 plus 1 divided by 1 plus 3, which is 2 by 4. So it's 1 by 2. And when x is equal to minus 3, we have minus 3 plus 1, which is minus 2, times 9 plus 3, which is 12. One second. Minus 1 by 6. So this is minus 1 by 6. So the points, the stationary points are 1, comma 1 by 2 and minus 3, comma minus 1 by 6. Sketch C, stating the coordinates of the intersections with the axis. So this is the graph, the xy plane. So this is x and this is y. Okay, so first let's find the intersections. So we have it's x square plus 1 by x square plus 3. So x square, just x plus 1. So one intersection will be at minus 1. And at x is equal to 0, we have 1 by 3. So this will be 1 by 3. This is the y-intercept. Yeah. And let's find the stationary points also. So we have 1 and 1 by 2. So at 1, so there's this one. This is the stationary point 1, 1 by 2. And at minus 3, we've got minus 1 by 6. So somewhere over here. So, and also y is equal to 0 is a asymptote. So it will look something like this. It will never actually touch the line, but that's how it will look like. So you can also plot it on a table in your calculator and just give a rough sketch. Sketch y square is equal to x plus 1 by x square plus 3. So we have y square is equal to x plus 1 by x square plus 3. So we have y is equal to plus minus square root of x plus 1 by x square plus 3. Okay. So just what that means is all the points of that previous graph will just now be rooted. So this stationary point was 1 and 1 by 2. So it will now become 1, 1 by root 2. This point was now 1 by root 3. So this intercept stays the same, which is just minus 1. And also because you can't take the root of the negative portion, that part will be empty. So it'll just be something like this. And it gets mirrored on the bottom side also. So we have this intercept also, it's minus 1 by root 3. So that's that question. The curve C has polar equation r square is equal to sine 2 theta cos theta. Sketch C and state the equation of the line of symmetry. So it's polar graph. like this. So again, so for this one, you're definitely going to have to need to use the table function on your calculator. So just input for theta is equal to 0, theta is equal to pi by 2, and theta is equal to pi, and all the other values like theta is equal to pi by 4, like that. Theta is equal to 3 pi by 4, and this line, this one, theta is equal to pi by 8, theta is equal to 3 pi by 8. So you just want to input like that and kind of look at what it looks like. So I've already done this, so I'll just go ahead and draw it. So it looks something like this, and it's symmetrical across the. It's actually symmetrical across this line. Theta is equal to pi by 2. So the line of symmetry is theta is equal to pi by 2. Find a Cartesian equation for C. Okay, a Cartesian equation for C. So you should know these fundamental things. So x is equal to r cos theta and y is equal to r sine theta. So the equation they gave was r square is equal to sine 2 theta times cos theta. So if you look in the formula sheet, they give this formula. Sine 2 theta is equal to 2 sine theta cos theta. So this just becomes cos square theta. Okay. So sine theta we can solve as y by r, and cos theta we can make it as x by r. So substituting that here, r square is equal to 2y by r times x by r square. So we have r to the power 4 is equal to 2yx square. This is actually r to the power 5 is equal to 2yx square. And also remember this r square is equal to x square plus y square. So this r to the power 5 we can write as r to the power r square to the power 5 by 2 is equal to 2yx square. So x square plus y square to the power 5 by 2 is equal to 2yx square. So this is the equation, final equation. Find the total area enclosed by C, which is this area. Okay, so what we can do is just take so the integral of a polar curve is just half integral of r square d theta. Half times integral from 0 to pi, because that's where the bounds of the curve of r square, which they gave as sine 2 theta cos theta. And d theta. Okay, so we can write this as half times from 0 to pi. Again, rewriting this is converting sine 2 theta to 2 sine theta cos theta cos square theta d theta. So this 2 will go outside the integral and cancel like this. So it becomes 0 to pi of sine theta cos square theta theta d theta. Okay. Now what we can do is we can do u substitution. So we can write u is equal to cos theta. So du by d theta is going to be equal to minus sine theta. So d theta is equal to du by minus sine theta. So substituting this value for u and d theta, so we get integral from, okay, I'll tell you, because when we do u substitutions, we always have to change the bound of integral. So because it was before 0 and pi, now it will be cos of 0, which is cos of 0 is 1, and cos of pi is minus 1. So times sine theta times u square times du by minus sine theta. So this sine theta and sine theta cancel, and we get this minus also, we can take it outside, and we get minus integral from 1 to minus 1 of u square du. And when there's a minus sign, you can always switch the bounds of the integral, like reverse it. So because right now we notice that the larger number is on the bottom, right? So it becomes minus 1 to 1 u square du, which is just u cube by 3 from minus 1 to 1. So what's that? That's just substitute 1 and we get 1 by 3. 1 by 3 minus, substitute minus 1, we get minus 1 by 3. So 1 by 3 minus minus 1 by 3, we get 2 by 3. And this is the answer for the total area enclosed by C. Find the greatest distance of a point on C from the pole. So they're asking us to find like the greatest distance. Okay. So this happens when dr by d theta is equal to 0, right? So we have r square is equal to sine 2 theta cos theta. Sine 2 theta cos theta. So if we do implicit differentiation on both sides, we get 2r times dr by d theta is equal to, okay, so we have to do the product rule here. Just so it becomes sine 2 theta times minus sine theta plus derivative of sine 2 theta will be cos 2 theta times 2 times cos theta. Yeah. And this dr by d theta is 0, right? So we get 2r times 0, which is just 0, 0. So we have 0 is equal to minus sine theta times sine 2 theta is equal to 2 cos theta times cos 2 theta. So moving this side, we get sine theta times sine 2 theta is equal to 2 cos theta times cos 2 theta. So dividing cos theta and cos 2 theta, we get tan theta times tan 2 theta is equal to 2. And actually we have to solve this is equation tan 2 theta. MF19 actually gives the formula. The formula is tan of 2 theta is equal to 2 tan theta by 1 minus tan square theta. So we just substitute that over here. So we have tan theta times 2 tan theta by 1 minus tan square theta. So this tan theta times tan theta becomes 2 tan square theta by 1 minus tan square theta is equal to 2. This 2 and 2 cancel. We have tan square theta is equal to 1 minus tan square theta. So 2 tan square theta is equal to 1. Tan square theta is equal to 1 by 2. And we have finally, okay, I'll write it here. Tan theta is equal to 1 by root 2, where theta is equal to tan inverse of 1 by root 2. So we have this one. So finally, all we need to do is just substitute this in the formula for r square is equal to. So we have r square is equal to sine 2 theta cos theta, right? So if we find r, it's just going to be this square root of cos theta times sine 2 theta. Substituting this value of theta, we get we get 0.877. R is equal to 0.877. So that's it.
Thank you so much, everyone. Looking forward to see you in the next episode with another past paper with Siddharth. Thank you.